PowerPoint. Fine, let's go to the session. Yeah, so brief introduction about our institute. So we are one of the very best VLSI institute, providing 100% placement assistance to the students who are joining with us. So you can be a fresher or working professional who wanted to switch your working domain to VLSI. So the tools and everything, whatever we are providing, they are industry standard, and we are going to provide you 24/7. So there will be a VPN along with the virtual machine, Linux-based virtual machine given to you. So you can access the tools anytime, whenever you are comfortable. So you just need to install the VPN software in your personal computer and laptop, and you can just start using it. Trainers, everybody whoever going to take the classes, definitely they'll be having at least 15 plus years of industry experience, and majorly most of the trainers, they are from reputed MNC companies and having a very good experience in the domain. We are providing you 100% placement support and training materials, mock interviews, everything we are going to provide you. So that is one of the wonderful thing what we can get with the upgrade VLSI. So this session can be as much as interactive. So if you have any questions, please feel free to interrupt me anytime. Okay, I'm happy to answer the questions. So why you should select our institute? So as I told in previous session, slide, so you will definitely find expert trainers. So compared to any other institute, so the trainers are whoever going to teach you. So they are having a very good experience in major MNC companies, and they are having a knowledge on across the nodes, right from the higher nodes to the smallest FinFET range. So they can train you very well, and yeah, definitely it will be helpful for you. And we are providing 100% placement support till you get placed. So the tools and softwares, whatever we are providing you, they will be available for you. So the virtual mission we are going to give you, that will be there till you get placed in any of the company. The mode of the course will be online, and the fee also we are charging very less only compared to the any other institute. And one good thing with this is whenever you have you can attend this classes from your home itself. You need not to travel to anywhere, as the complete course is online. So related to the batches and all, I'm going to discuss in the further slides. And the tools also, as I told you previously, so they are very powerful tools, and 90% of the companies will use the same tools which you are going to learn during the actual classes. So that is a one good benefit for you guys. So in VLSI, like analog layout kind of jobs, definitely 50% your knowledge will be helpful, and another 50% is the command on the tool or the software which you are going to use. So in that part, that 50% related to the tools, definitely whatever tools you are going to learn in this particular program, so they are like industry standard, and if you join in any of the company, 90% they will be using the same tool or at least a similar tool. Because some competitive companies, they will be having a different tool, but majorly these tools which we are going to teach you, they are like most of the companies will use the same. So there is a key training information. So you can get the complete details in the above link. So if you want, you can take the screenshot of this particular slide. Okay, so duration of the course will be 4 months, and mode of study will be online, and there are two types of batches will be there. One is the daily batch, where 1 hour each daily there will be classes, and lab will be like lab will be available for you 24/7. Lab in the sense like the tools and all whatever we are going to provide you. So whenever you have a free time, you are free to use those tools. Okay, those are available 24/7. Only the sessions, actual teaching sessions will be 1 hour per day for daily batches, and 3 hours per day for weekend batches, both Saturday and Sunday. And course materials, everything will be provided to you. Most of the things will be soft copies, and if anything hard copy is required, so those things will be couriered to you, whatever address you are going to provide. Okay, so if you need any further information, please feel free to write this to this email ID, or you can directly contact to the number. or the best way is that you can talk to the HR person, whoever in touch with you. Any questions so far?
No.
Yeah, thanks. Are you able to follow it, right? So this pace is okay, or you want me to slow down?
It's fine.
Okay, good. Thank you. So who are eligible for this course? So if you are already completed your BE, BTech or in diploma with electronics as one of the your core subject, then you are eligible for this course. Maybe you are a fresher, or if you are already completed your MTech also, and if you wanted to pursue your career in VLSI domain, definitely this will be a right opportunity for you. And already you are working in somewhere like in software domain, and if you wanted to switch your domain also, definitely this will suit for you, definitely. And what are the industry standard salaries for this particular domain? So as a fresher, definitely there is a chance that you will get 4 to 6 lakh per annum. And if you have around 3+ years of experience, it will be like 12 to 15 lakhs per annum. And if you are like 10+ years of experience, and if you have a managerial skills as well, then there is a very high chance that you will go up to 50 to 70 lakh per annum. Okay, so these are the industry standard numbers. There will be plus or minus some variation could be there based on the personal talent and all. So this is not a maximum number. Okay, so if you are good at your work, then definitely your number will be much higher than this. So placement support, as I told before, so we are going to provide you 100% placement assistance till you get placed. So we are having around 200+ companies, which includes product-based companies, service-based companies, and some of the startups as well. So whenever they have some opportunity, right, definitely they'll come to our institute, and they'll recruit based on their requirement. And the tools and the interview support you will get till you get placed. And the minimum package what till now we got is 4 to 6 lakh per annum as a fresher. So definitely if you wanted to switch your career, or if you want to start your career in VLSI domain, then this will be the right place for you. So these are the some of the companies, and if you wanted to know the full list, then please visit our website, so you can get all the list there. So you can find like very big companies like Global Foundries, AMD is there, Xilinx is there, Western Digital is there, Synopsys. All these are like big MNC companies. So let's go to the course. Before going to that, if you have any questions so far, I'm happy to answer. If not, we will start the actual curriculum. Or what are the things you are going to learn after joining the course? So this day, sorry.
You can start.
Yeah, thank you. So we have around 13 modules in the course. So 12 modules will be purely technical, and that is related to the analog and mixed signal layout. And 13 module will be like your resume preparation, mock interviews, and course completion test will be there. So we are going to conduct one test for you after completing the 12 modules. You need to attempt that course, and here you can just see the teaching hours and lab hours for each concept, each module. So anyway, I have an individual slide for each module. So if you have any questions, you can ask right now, or you can ask during the individual slides also. Okay, so I will just run through these modules. Maybe we will discuss more when I'm going to explain you about each module. Okay. Yeah, so very first module will be Linux and Unix based operating system basics and all. So for many of the people, so Linux based operating system will be new, and the reason for placing this module as a very first module is, so the most of the softwares which you are going to use or which you are going to learn, they will support only Linux based operating systems. So definitely if you wanted to use the tool, and if you wanted to learn the tool, you should be familiar with the operating system also. So there are certain commands you need to learn, so which will make you comfortable whenever you are using the tool, or whenever you are doing some day-to-day activity in your company once you join in some XYZ company. So this Linux based knowledge is very much important. So even though it is not part of analog layout, so we introduced that as a very first module, so that you will get some command. But some people, if you are already having a knowledge on the Linux operating system and all, it is well and good. Okay, so definitely if you have any doubts, this is the right place where you can just clarify your doubts and all, and you can improve yourself. Second module will be introduction to the electronics and circuits. So where we are going to explain you about the MOSFETs and some of the second order effects in that, and the basic CMOS structures. And most of these concepts will be like in your curriculum, like BTech concepts only. But we wanted to revise all those concepts, because from the third module itself, it will be like purely related to the industry standard topics. So before going to the industry standard topics, we wanted to just I mean, some people might be having the some gap in their uh, regular things, right? After completion of their BE Tech, maybe they are into different domain and they wanted to switch. So for them, definitely this module will be much helpful, so that you can just revise your knowledge on the core concepts. Third module will be latch up antenna effect. These are called as a design for manufacturability checks. In short, we will call it DFM. Maybe this word, it will be very new for you guys, but once you join the course, you will understand all those things. So these are the some of the things which you need to follow whenever you are designing the layout. So if you follow that, then you can expect that your layout will perform after fabrication as you expected. I mean, layout, that mask will be converted, sent to the fabrication plant, and that will be fabricated, right? So once the chip comes out from the fabrication plant, so if you follow all these phenomena, there is a very high chance that your design chip work as per your expectation. So you need to learn all those things. Okay, module 4 will be deep submicron process challenges, where we are going to explain about the lower node challenges in layout. And fifth module will be introduction to the IC circuit layout, where we are going to explain about the CMOS fabrication technology and CMOS stick diagrams, and introduction to the layout also will start from here only. And the sixth module will be actual tool introduction, the software introduction, which you are going to use to design your further assignments or layouts. And the seventh module will be analog circuits and layout design techniques. So there are certain guidelines, especially for the analog related stuff. Okay, analog related circuits layout design, like matching, shielding, all those things you are going to learn in the seventh module. Eighth module is a standard cell techniques, where you are going to design some custom standard cells like a NAND gate, NOR gate, inverter with a different drive strength. So we are going to explain what exactly the drive strength and how it will impact the layout size. All those things will be explained in the module 8. Module 9 will be memory layout. So this is a different concept or a different thing compared to the regular analog mixed signal layout. But this is also one of the domain majorly people are going. So if you are interested in memory layout, so it is, I mean, the basic thing, the layout designing, everything will be same. But the circuits involved in your layout design and some of the guidelines will be different. That's all. So the memory layout design will be your ninth module. 10th, 11th, and 12th, all these three modules will be we are going to give you very basic circuits to the industry standard big projects in the 12th module. So you need to understand the functionality of that particular circuit. Like, let's say if I give operational amplifier, so what exactly that operational amplifier does, and what are the parameters you need to consider whenever you are designing that particular design or layout. And we are going to cover some simulations also. So this will be a basic simulation, where you just need to understand how exactly a circuit designer will simulate the designs. Okay, so third module, as I told before, so this will be like mock interviews, personality development, and your resume preparation, course completion test. Everything will be there in the module 13. So this is just a brief introduction. I'll just go and explain about each individual slide, each individual module in different slides. So yeah, this will be the right time. If you have any question, you can ask about any of the module. Any questions so far?
No.
Okay. Fine, thank you. Thanks for the confirmation. So first module is the basics of Linux. So don't get confused if somebody don't know what exactly the Linux is. So you know Windows operating system, Android operating system, and iOS, right? So Linux also it is something like that. It is an operating system only. So one of the flavor maybe Ubuntu or Red Hat, some Linux flavor operating system will be given to you. So there will be some commands you need to learn. Okay, so maybe in Windows also somebody might use your command prompt whenever you are writing your C code and all. So something similar will be there in Linux also. So most of the things you need to go with the command line only. But equivalent GUI options also will be there, graphical options also will be there. But generally most of the people will prefer command based because that is much easy if you are comfortable with those commands which you are going to use. So two examples are given over here. So like if you wanted to copy some file, we'll use generally CP command. And if you wanted to copy the complete directory, generally we'll use CP-R. That R means it is a recursive, means like the complete contents of that particular folder or directory. Windows will call it folder, but Linux generally will call it as a directory. Okay, both are same, don't get confused. Okay, so in Windows we'll call it as a folder, and here it is a directory. Okay, if you wanted to copy the complete contents, doesn't matter what files are there in that particular directory. So if you want to complete that, completely copy that to a different location, generally we will use CP-R. I will show you how exactly that Linux based operating system or Linux based virtual machine will looks like. Okay, whenever I'm whenever I'm explaining the module 6 where the tool related interaction is there. So I'm going to bring my virtual machine and I will show you how exactly that Linux based operating system looks like. Okay, any questions here? Okay, fine. So module 2 will be your introduction to the electronics and circuits. So before going to this, I just wanted to understand, do you guys have a knowledge on CMOS structures and how exactly CMOS, I mean, a CMOS topology will be fabricated, CMOS MOSFETs will be fabricated, both PMOS and NMOS?
Not in depth, but on just the basics, college level.
Okay, okay. So you have your VLSI subject in your curriculum, right? So fabrication process and all.
Fabrication we don't have, but we have cross section of CMOS.
Oh, okay. This is what you are seeing right now. Okay, good, good. So generally, whenever we are explaining about CMOS, right, we will see a cross-section view only. So whatever right now it is there on the screen. But one thing you should remember, whenever you are designing the layout, you can't see the cross-section view. You see the top view. Same structure, nothing will differ. Okay, I will show you that also. Don't worry. Okay, but just keep this in mind. So whenever you are designing the layout, you will see the top view of the chip or top view of the this CMOS structure, both PMOS and NMOS. You will not see the cross-section view. Okay, there's just one point, you just keep it in mind. So whenever I am showing the tools, right, I will show you the exact comparison, how exactly it looks like whenever you are seeing it from a cross-sectional view and the top view. Okay, so this module we are going to cover CMOS structures and what are the layers to be fabricated. All those things will be explained over here, and this will be like a basic. I mean, it's not basic thing. Okay, so it is a bridge between your academics to the actual course. Okay, so whatever it's been discussed in your academics, right? So we are going to revise them and we are going to explain some of the new concepts which are required for the course. Okay, so if you forgot or if you don't have these concepts, then definitely this is the right place, and you can learn all those things. And third module will be your I mean, from here it will be like purely related to the actual analog layout design. So these are the some of the concepts you need to some of the things you need to follow whenever you are designing your layout. Okay, if you don't follow this, maybe your circuit will not function as you expected. Okay, so you are expecting gain of some dB, and that will not come if some of these parameters are failing. Okay, so these are the some of the things we are going to explain theoretically what exactly this particular thing means, and what if you don't follow this whenever you are designing the layout. If you take latch up, okay, that is one of the concept, like if you don't follow the latch up rules and latch up guidelines, okay, definitely your chip will not work as you expected. Okay, either it will damage or it will malfunction. Okay, so like that we have antenna effect, we have electromigration, IR drop, self heat. So these are the some of the things which you need to learn theoretically and you need to implement whenever you are designing the layout. Okay, so those things will be covered in the module 3. So if you are not aware of these terms, don't worry about it. Okay, nobody knows before joining the course and before coming to the actual work. Okay, so if you don't know this, and no problem at all, so we are going to teach you. Okay, so just to give the information about what and all things you are going to learn, I'm just trying to explain this. Okay, don't worry about it if you don't know it. And fourth module will be deep submicron process challenges. Maybe if you have a process, I mean CMOS process steps in your curriculum, maybe that is purely related to the higher nodes like 180 nanometer and 360 nanometer. But when it comes to the lower nodes like 60 nanometer, 40 nanometer, or 11 nanometer, or even 10 nanometer, different nodes are there from the different foundries. Okay, so coming to the lower nodes, generally lower nodes will call it as a deep submicron processes. Okay, so there are additional challenges we will face. Okay, so whenever there are challenges, right? So from layout side, we need to follow some of the additional guidelines from for these. Okay, so some of them are like shallow trench isolation, well proximity effects, length of diffusion effect, metal densities, and there are like base layer densities also. Generally we will call it as front end layers. Okay, all those things we are going to explain in the module 4. Okay, so don't worry if you don't know any of this. Okay, and fifth module will be your introduction to the IC layer circuit layout. So where we are going to teach the fabrication technology, and from the circuit like this to this, I mean, how exactly a circuit designer is going to give you some circuit and what exactly you are going to design. So the bottom one is a stick diagram, but you are going to learn the layout, not a stick diagram. So stick diagrams used to, I mean, people used to use a long back, but now everything is a layout only. So you are going to draw exactly whatever circuit is being given to you. So you are going to draw the a layout for that. So now it comes to the tool introduction. So I will show you the tools, and I will show you how exactly this virtual machine looks like. So before going to that, I just wanted to give the like names of the tools, whatever we are going to use. So there are two different types of softwares which you are going to use, or which you are going to learn during your course. One software is for designing the layout. So if you wanted to design the layout for, let's say, circuit designer came and give you some inverter circuit. Okay, you wanted to implement the layout for it. Okay, so that from the inverter circuit given to you, you need to realize the layout for it. Okay, for doing that, you need a one software for designing the layout. Okay, that is Cadence Virtuoso. We are going to use Cadence Virtuoso for designing the layout. Okay, but after you designed it, let's say you are a fresher and you are not sure about all the guidelines required for that. Okay, so who will check the correctness of that layout? Okay, whether you draw inverter or some NAND or NOR gate, nobody knows. Okay, so to check the correctness of that layout, so there are some certain checks it has to run. Okay, so for checking that, verifying the your layout whether you have done it properly or not, we will use physical verification software called Caliber or Assura. Both are purpose is same, but the tool vendor is different, tool company is different. Okay, one is from a different company and another one is another company. Okay, but the purpose will be same. Any questions?
No, sir.
Okay, good. So you are able to follow it, right?
Yes.
Okay, good. Thank you. So After the tools, like what are the checks you need to follow? So here are the three checks we have. So DRC, LVS, and ERC. So these are the short forms. DRC means design rule check. LVS means layout versus schematic. ERC means electrical rule check. If you want to note down, you can note down these names. Anyway, we have another slide for them. I will explain that. Okay. So now let me take you to the virtual machine. Give me a minute. Where is my VNC? Okay. Share my screen. Let me know once you're able to see my screen. Able to see it?
Yes, we can.
Yeah. 1 minute. So this is the virtual machine, means like yeah, this will run on some server of our institute. Okay, so those credentials we are going to provide you. So there is a two softwares you need to install. One is the VPN software to connect to the institute's network, and another software is a VNC server, a VNC viewer, which you need to use it for connecting to this particular virtual machine. So whenever you open it, right, it looks like something like this. And if you open any terminal, right, so this is a command line terminal, or whatever you call it. Okay, so there are some commands you need to use over here. Okay, so now it comes to the software. So this is the software it looks like. So Virtuoso, and this is the version number, and it's been there is a log file associated in this particular path. So it looks like this, and the company providing this particular software is a Cadence Design Systems. Okay, so this window is called command interpreter window, or CAW. So whenever you open the schematic, so this is the circuit diagram for one of the operational amplifier. So generally you need not to create this. There is another person in your team called circuit designer. So he will create this schematic and he will provide to you. So what you need to do is you need to create a layout for it. Okay, so that looks like something like this. Okay, so this is equivalent to this. Okay, so whenever you wanted to send any chip for fabrication, right, generally we don't send this. Okay, because if you have some patented information and all, and if you have any critical circuit and all, okay, so we will not send this type of designs to them. Okay, we will send this. And other thing is foundry, they don't know how to fabricate this if you are not providing any layout view of it. Okay, so this is a physical form of it. Okay, this is a schematic format or circuit format, you can call. Okay, so this to this we are going to convert. That is our job. Okay, so yeah, let's say foundry, if we send this design to the foundry, if they wanted to fabricate poly, they will separate only poly mask. So this single layer called a mask. Okay, so they will take out this poly layer only from your design, and they will fabricate wherever you have these green color boxes are there, right? Everything is poly only. So whenever they are fabricating poly, the reference is your mask, this mask. Okay, they will fabricate the poly wherever you have a green boxes. And let's say when they wanted to fabricate P implant. Okay, so this mask they will separate from your design, and they will use it for fabricating the P implant. Same thing for N implant also. Okay, so there are certain layers which you need to understand, basically what exactly NVEL is. So this is the NVEL mask, what exactly oxide is, and what exactly oxide thick means. And poly, I think you guys are already aware of it. P implant, N implant, based on the doping type. Okay, so this will be decided. And a contact and metal. So metals, I think you may not be aware of it. I'll just give you a small explanation about it. So you have a MOSFET over here. Let me just select one MOSFET. Okay, so this one MOSFET, you are seeing it over here. Okay, so the source is connected to this particular MOSFET, and drain is connected to this particular MOSFET source terminal, and all three gate terminals are connected. Okay, so whenever you take a MOSFET, it will come with open terminals, only source, drain and gate. Even your bulk terminal also will not be there in layout. Okay, layout fourth terminal, bulk terminal, you need to place it separately. Anyway, that is a different topic which you need to you will learn in the course. Okay, so to connect these connections, basically what happening, this drain terminal is connecting to this source. Okay, so if I wanted to connect that, I need a wire for it. Okay, so generally in breadboard, if you are connecting one MOSFET to other MOSFET or one chip to other chip, generally what we will do, you will use a jumper wire. Okay, here the jumper wire equivalent to that is a metals. Okay, and you will be having different metals, metal 1, metal 2, metal 3, like that. If you have so many connections, then one metal will not be sufficient for you. So okay, you need an additional metal also. So generally what we will do, one metal we will use vertical connections and one metal we will use for horizontal connection. Okay, so all these are for the purpose of connecting one MOSFET with the other MOSFET or one pin to other pin. Any questions here?
No.
It's clear, right?
Yeah.
Okay, good. Thank you. Let me know if you have any questions. Okay. So this is how it looks like. So what exactly we are going to do, whenever you got some circuit diagram like this, right? You need to design the layout for it. And finally, this design only will be sent to the fabrication house. And based on this information, the physical information, this is called physical information or physical format of the design, which we are going to send it to the fabrication plant, and they will fabricate according to this, not according to this. Okay, because they don't know what exactly circuit you are sending it for fabrication. Anish, you have any question?
No, sir.
Okay, can you mute? Yeah, thank you. So this is how it looks like. So your tool, so there are like multiple options will be there on each menu. Okay, so one option, it will perform one operation in your layout. Okay, so all these op menus you need to explore. Okay, there are sub menus also. Okay, some places if you see here there are sub menus. Okay, so if you observe, some of the options are grayed out, meaning right now I opened it in reading mode. Okay, so these are the whatever grayed out options are there, they will be enabled only in editing mode. Here you are able to see, right, it is in reading mode. If I change it to make editable here, okay, all these grayed out options will be converted to the normal one. Okay, you can able to perform those operations. Okay, and another good thing is, let's say if you wanted to use any of these options. Okay, so always you need not to go to each menu and click that option. You need not to memorize all those options in the individual module. Okay, there will be associated bind key will be there. Okay, if you press E, this option will be executed. You can just need to click over here and you need to press that option. I just pressed E on my keyboard, so that popped up this option window. Okay, let's say if I go here and from where I do it, we connectivity display E. So if I click here, same window will pop up. Okay, two ways you can access. One way is directly coming over here and clicking on this option, or you can directly press the button. Okay, so each key on your keyboard will associate one function. Okay, those are called bind keys. So anyway, all those things you will learn whenever you are joined in the course. So this is how the tool looks like. Okay, so the other one for verifying the DRC and all. So here Ashura is given to you in the Ashura menu. So run DRC, run LVS, run ERC, and there are other options also will be provided to you. So this is how you need to launch it. So if you click on this, so it will run the DRC, design rule check. I will explain you what exactly that means. Okay, and LVS, layout versus schematic, ERC, electrical rule check. So this is how you need to run the verification checks. Any questions related to the tool?
No.
Okay, good. I think you are able to follow it. Okay, now going to the 1 minute. Let me stop sharing and share my whiteboard. So previously I told like in your layout design, you will see only top view only, but in your books and all, you will see the cross-sectional view. So you're able to see my whiteboard, right? So the bottom one is the cross-section view, generally what you will be having in the book. And the top one is the one I have drawn. So this is how actually you see in the layout. Okay, you will be having a P substrate. So generally P substrate will be your background only. There will not be any layer for the P substrate. So whatever it you have a black background in the layout, right? That itself considered as a P substrate. Because by default we are sending it with a P substrate and anvil process. Okay, so and whenever you wanted to fabricate an PMOS, you need to form an anvil over there. So you'll be having anvil like this. Okay, and in a cross-sectional view, that particular anvil looks like this. Okay, so and whenever you want to fabricate poly, so that poly mask will be taken and your poly looks like this in your layout. So this actually what I wanted to explain is, so this is how actually you learn in your curriculum, and you learn how exactly the cross-sectional view looks like. But the major difference from that to the layout is, layout you see only the top level view, not the cross-sectional view. So you need to relate this. So if you see this P plus is related to this P plus bulk connection, source and drain terminal, source and drain terminal. So this area is N plus, this area is N plus, and this is a poly, which is a gate terminal over here. Okay, and this red color one is the N well, which you have like a tub kind of structure over here. And both sides, source and drain, source and drain, these are P implant type, and N plus is a bulk, which is associated over here. Are you able to like visualize it, or
Yes.
yeah, good, thank you. So this is how actually the layout looks like. So yeah, let me go to the further slides in the presentation. So I shared my PPT again. So now it comes to the verification checks, whatever we need to perform, like LVS, DRC and all I told, right? So first let me go with the LVS. So if you see the right side example, the very first one is the schematic view or circuit view, which we got from the circuit designer. Okay, for that equivalent of this you need to implement. Okay, so you implemented it with a cadence virtuoso, but somewhere some tool should be there which will verify, right? So that is like you will use the same tool for DRC and LVS, even for ERC also, which is a Caliber or Assura based on the availability. So here layout versus schematic. So this is the layout and this is the schematic. So the connectivity and the parameter, both it will check whether, like if you see here, this source is connected to power supply or not, it will check, and this drain is connected to this particular output connection, why or not, or this source is connected to power supply or not. So this is a connectivity comparison. Okay, so there are two types of comparisons will be there. One is the connectivity and another one is the parameter. So whether your connectivity is proper or not, it will check first one. Okay, if let's say your connectivity is proper, the another one it will check for is a parameters. Parameters means something like your length of the MOSFET, width of the MOSFET, number of fingers, number of multipliers, all those things comes under parameters. Okay, don't get confused by thinking all these concepts. Okay, don't worry about it. Okay, you will learn all those things once you join in the course. Okay, so I'm just trying to explain you what exactly this LVS compares for. Okay, so connectivity it compares, and the parameters, what exactly, whether you put the same gate length or not, whether you put the same diffusion width or not, all those things will be compared. And other one, the left side one is a DRC, design rule check, where generally just let me take you one example. Let's say you are working with a technology called TSMC 28 nanometer. Okay, the 28 nanometer TSMC technology is provided by the TSMC, Taiwan Semiconductor Manufacturing Company. Okay, so that is a fabrication plant. Okay, so if you wanted to fabricate your design in that particular node or particular technology, so there are certain guidelines or certain rules you need to follow. Those guidelines and rules generally will be given by the fabrication house. Okay, in our case it is TSMC, and the technology you are doing is 28 nanometer. Okay, so in 28 nanometer, let's say a metal should have this much width and metal should have this much length, or your poly, the minimum length is this much, the poly maximum length is this much. So something like that, some rules will be there. Okay, so over the experience you will remember all those rules, and uh, you will do correct by construction design. Like whenever you are designing the layout itself, you will know like this is the minimum width, you already aware of it. Okay, you will put maybe the minimum number or more than that. Generally you don't put lesser than the minimum number. Okay, so but in the beginning stage you don't know all those rules. Okay, so for that we need to run the DRC check. Okay, that will verify whether whatever design you have done, that is fabrication possible or not. So fabrication possible or not means how you can say, so if you pass all the design rules given by the foundry, then that will be accepted for the fabrication without fixing all those DRC errors, right? So if there are any violations, if you violating some rule, okay, that particular tool will report you. So okay, this particular rule is violating over here, you have to fix it before sending it for fabrication. Okay, so that will guide you how to fix. Also there will be some help information given to you, so by following that information you need to fix that. Okay, any questions in DRC and LVS? ERC also something similar, so it will check for the electrical things. So DRC and LVS both, it checks for the connectivity related and physical related, and ERC checks some electrical related things which we are anyway going to cover in the course. Any questions here? Okay, good. So finally, 7th module to 12th module, I think here, oh, sorry, this is theoretical module only, sorry. So here we are going to explain matching, shielding, and what is interdigital matching and what is common centroid matching, and which matching technique should be used where. All those things will be explained over here. So these are specifically related to the analog layout. Okay, so all transistor level, one transistor level circuit, like you are seeing it here, right? The differential amplifier will be given to you. So you will be having current mirrors, differential pair, everything over here. So you will understand all the requirements, what you need to follow for designing this particular block. Okay. 8th module will be standard cell technique, standard cell layout design techniques. So where you will be designing NAND gate, NOR gate, and all. And one inverter we will take with a different drive strength. So let's say if the drive strength is changed, what exactly changes in a, for a circuit design, inverter symbol looks same. But when it comes to the layout, so your actual layout size will be different. By increasing the drive strength, your number of devices or number of fingers or multipliers will get increased. So how exactly you need to lay out for such blocks, all those guidelines we are going to explain in the 8th module. 9th module, we are going to cover memory layout, where 6 transistor bit cell, row column decoders, a sense amplifier, pre-charge circuit. Don't worry, all these are the functional blocks in the memory layout. Okay, so if you wanted to pursue your career in memory layout, okay, this will be the very right module for you. Okay, so if you are interested, then definitely you can explore all those blocks, and you can learn it thoroughly, and you can go for the interviews. Okay, so this is also another domain. So the tools, everything will be same, only the circuit which you are going to deal with will be different in memory layout compared to the normal analog mixed signal layout. Okay, remaining everything will be same. Tools will be used, same tools, and your verification methodologies are same, and your fabrication guidelines will be same, everything will be same. Okay, So module 10 to 12, we will start with a very basic functional block, which anyway already we started in the module 8, that operational amplifier. Okay, and followed by we are going to give you reasonable sized blocks, and and then finally we are going to give you the industry standard big blocks like PLL, LDO, band gap reference, VCO, everything will be covered. So these designs, we are going to explain the operation of that particular circuit right from the scratch, okay, transistor level, and we are going to guide you how exactly you need to design the layout for it. Okay, so you need to design the layout completely for the particular all the blocks in a given lab sessions, and you need to perform LVS, DRC, and if any other verification checks like ERC and all, everything you need to perform. And if any violations are there in your design, let's say your design is not matching with the circuit given to you, okay, so you need to fix all those violation and even the DRC rules also, everything you have to fix. And there will be another instructor who will review all your designs, okay, and he will provide you maybe the best practices whenever you are designing the layout, okay, make you comfortable with the tool, and whatever major things, because these blocks are individual blocks are different, and you need to follow different guidelines for these block. Okay, so all those things we are going to cover in this 10 to 12 modules. Okay, so here more of like lab sessions will be there and interactive classes will be there for you. And finally, the third module will be your mock interviews and resume preparation, and course completion test will be there. We are going to support you through the interviews and all. So all those things will be there in the 30th module. Okay, so this is the brief introduction about the course, what exactly you are going to learn. Okay, yeah, so that's all I have. So we have around 4 more minutes. If you have any questions, please let me know.
Hi, sir. What is the technology node while we are going to learn?
It's 28 nanometer. And we are going to provide you some introduction to the FinFET related things also, because right now industry standard mostly they are going with the FinFET, right? But I have experience on FinFET, right? So there will be few guidelines it will you need to learn extra, that's all. But most of the things layout wise, good thing is everything will be mostly same. Some additional rules and guidelines and you need to follow, that's it.
It is TSMC or GF?
I think it is TSMC if I'm not wrong.
Okay, sir.
Any questions? Anish, NK, I don't know the full name, sorry.
No questions.
Everything is clear?
Yes, sir.
Okay, good. I think Anish, you joined little late. So we recorded this session. Maybe you can get the credentials from HR. Okay, maybe you can follow the course. You joined in between, right?
Yes, sir.
Okay, yeah, I think if you have any question, please let me know. I'm happy to answer you.
No questions.
Okay, thank you. Let me stop the recording.